So yeah, we'll jump right into it here with testing QoS and going over exactly what it is we're looking to do anytime we're testing, and performance in general, but especially with QoS. There are challenges, and one of the places you like to start is kind of knowing where you want to finish, right? So with any type of testing, you want to, what is your end goal? What are you looking for? With QoS, we talk about thresholds and other different test parameters that we're looking to meet to ensure that all traffic is getting handled in the way that we expect. One of the challenges with generating that traffic is actually marking it and separating different traffic types. So we'll talk later and go into how CDRouter generates these traffic flows, as we call them, and how we assign those markings. One thing with QoS is we actually have to create the correct conditions in order for the queuing to occur and for the device to be experiencing the congestion, the type of scenario needed to determine which traffic gets what kind of priority. We've done some things in CDRouter to ensure that that happens and that QoS is actually able to take place. And there are certain situations where it can even detect that, hey, maybe things aren't quite right and the queuing you thought might be happening isn't actually happening. So we'll look at what happens in that case as well. Of course, it's performance testing, so we're going to determine the good put and look and see exactly what those metrics are. Compare those against the initial thresholds that we set out at the beginning. And then, of course, being CDRouter, we're able to repeat this testing and remain consistent through each test case. So our tests are organized into 4 new modules, download and upload versions of each. And of course, IPv6 and IPv4 for each. We'll talk about this more later in terms of configuration, but these are fixed test cases, similar to, if you're familiar with them, our fixed rate performance testing. You can consider these fixed DSCP performance test cases. And we did that for a number of reasons, but mainly for simplicity on the CDRouter side. This makes it really easy to know exactly what you're testing and to minimize any sort of extra configuration that, in all honesty, can get really complicated really quickly. So once we dive into the demo side of this, I'll go through in a little bit more detail how those tests are organized. But these are the 4 new modules that appear. So each module has the same set of tests, which is really good, whether it's upload, download, IPv4, IPv6. It's the same set of tests that have different combinations of, again, what we call flows. And I created this moniker of an application flow or the primary flow, as well as a background flow. And then there's different combinations of transport protocol. So we have different traffic flow types: video, voice, bulk, which is a little bit interesting. I'll mention more about that in a moment, and best effort. So video and voice, pretty self-explanatory, run over UDP. Best effort is truly everything else that we expect to run at a best effort level. Of course, that could be TCP or UDP, and there is no marking on the best effort traffic. Bulk traffic you can consider to be sort of like a trickle download or a trickle upload. Think of something that might be doing a file sync or some sort of backup, something that it's okay for it to be long running. We really just we want it to end eventually, and we really don't want it to impact any of our real-time activities. So again, that could be TCP or UDP. And how do we come up with those? Well, I mean, video and voice is pretty obvious that those things would happen on them, but there's a little bit more that goes into figuring out the code points and what we actually want to aim for as far as setting up our queues for our traffic flows. So what we came up with was leveraging diffserv4, which is defined by the Cake queue management system. Cake is gone through a couple of renamings, I think, and acronyms. I think right now that stands for Common Applications Kept Enhanced. But I include the link here to the Bufferbloat project, where they have more information in great detail about how the Cake modeling works. But the important part that we need to keep in mind here for our purposes for QoS testing is that diffserv 4 specifies 4 different tins or diffserv and just diffserv markings for those tins. We'll talk about these thresholds a little bit here. Basically, the idea behind these thresholds is that they set a minimum expected rate of traffic that would flow through the system or to flow through the interfaces, as the case may be. So you can see the percentages here. Video, we'd want to have a minimum threshold of 50% of the available bandwidth. Voice at 25% of the available bandwidth. And bulk, as I mentioned before, is sort of just a trickle. We want it to keep going and eventually finish, but it doesn't need to take up very much at all. So that's set at 6.25% of the bandwidth. You'll notice I didn't include a percentage here for best effort. Truly, that would be a minimum. You can either think of it as 0 or 100%. Basically, it's whatever is left, right? So if you happen to have, a video stream and a voice stream, you'd be using, a minimum potentially of 75% of the bandwidth, and best effort would take up the remaining quarter. One other note about this is, supposing you had multiple video or voice streams, they don't each get allocated 50% of the available bandwidth. They would fall through the same queues unless something different has been done to the configuration in terms of per host queuing or per port or per application, something different like that. They'd still fall into the same queue. So all video streams would get up to 50%, and all voice streams would get up to 25%. And that should be sort of obvious once you think about how the traffic would add up over time. And I should say one more. There's a lot out there on diffserv and the code points. So we've included some references at the end that we'll be sharing when the slides go out. But there's definitely a lot more than we're able to cover in terms of DSCP and diffserv in this presentation. So hopefully the thresholds we mentioned will be good enough to get us going. So I mentioned earlier about, part of the problem with queuing and ensuring that the quality of service contract is being met is that we actually have to have conditions under which it makes sense to do quality of service queuing and prioritization of traffic. If the DUT isn't under enough load, isn't doing enough work, there's not enough traffic, there's really no need for QoS to take place. So we need to be overwhelming the device in order to cause those queues to fill up and for the device to make those decisions. Simply just slamming a single port with, supposing a gigabit per second port, may not be enough, right? It depends on where the traffic is destined to and what the speed on the other side, on the other port may be. So there's a couple of ways of doing this. I use the term asymmetric here in terms of WAN and LAN speeds. So supposing you had a WAN port that was, say, 2.5 or 10 gigabit per second and gigabit WAN ports, or LAN ports, that would be a situation where it would be pretty easy to overwhelm the device from the download direction. I'm going to be talking about download versus upload direction because they are different in terms of what you can do in as far as QoS. You could also do this with just simply the number of WAN and LAN ports. If you have 4 gigabit per second LAN ports and a single gigabit per second WAN port, then again, it's pretty obvious to see how we could overwhelm the device in the upload direction. Another way of doing this, and it kind of goes hand in hand with these other models, is just to increase the number of clients we're using. So again, these are all things that CDRouter will help us with and sort of guide us through as we're running testing. So now we'll dive into a little bit of the test setup and what this looks like from the CDRouter point of view. So when we do dive into the demo here momentarily, I thought it would be helpful just to have an idea of an image in our head of what the topology looks like. And again, this is just an example topology. It's probably not like one that you would be testing with in your own labs. However, this is enough to generate some good results for us and to explain what's going on for the sake of the presentation. So in this topology, we have a single WAN port, gigabit per second, connected up to ETH1 of CDRouter. And we have a couple of LAN, well, actually 3 LAN interfaces. One is a wireless LAN, 802.11x, and the other 2 are gigabit per second Ethernet ports connected to Wi-Fi 1AX, ETH2, and ETH4. So with this DUT, we'll experience congestion in the upload direction when all clients are transmitting at or near line rate. So what I mean by that is there'll be a client on each of our LAN interfaces. From the CDRouter perspective, Wi-Fi 1AX, ETH2, and ETH4, generating traffic into the DUT somewhere around 60 to 70% of its line rate to a client on the WAN side on ETH1. So in that way, the DUT's going to have to determine which traffic needs to be prioritized according to the thresholds that we mentioned earlier, and we'll use CDRouter to determine that those thresholds are in fact being met. So CDRouter configuration, and after this, we'll dive in a little bit to CDRouter just to explain how this works in the example terms. So the good thing here is on the CDRouter side, there is very minimal configuration required. Most parameters are fixed, and nearly all parameters are fixed according to the test case that we'll go over, and I'll point out momentarily. This is really good news. It makes it really easy to get testing go off the ground and to get some results, really early in the process and start getting that feedback loop going as soon as possible. I will point out that the duration of the performance test case can be modified, as well as the port. If there's a reason to change ports, maybe you're testing a different queue or something that's some different defaults, we can change those things. I'll speak more about duration in a moment, because while you may be familiar with perf duration from other performance tests in CDRouter, how we use duration for our QoS testing is slightly different. So just to look at an example test here, and it's maybe tough to see, but this top line is the actual test case name, and what follows is the breakdown of what this test is actually aiming to do. So as I mentioned earlier, it's a perf DSCP fixed test case, IPv4. It's test case 12, and what this is a download test using voice as the primary or application flow, voice over UDP, and a background flow that's also voice over UDP. And I've just broken that down here for future reference. So let's switch to CDRouter for a moment, and we can just take a peek at what this looks like in terms of the configuration. And you'll notice, as I scroll through here, much of the configuration is actually collapsed or commented out. In other words, there isn't very much set here. And I'll kind of go in reverse order just to kind of prove and emphasize that point, that our performance section, although I have things like download bandwidth and interval uncommented, even perf DSCP in this case, these test vars are not actually being used. The only ones that are being referenced here are perf duration, and perf port would be used, but you'll notice I also have that commented out. So there really isn't much to do down the perf section here. Probably should enable supports performance, however. So scrolling back up to the top, it is something that I want to point out here in terms of our interfaces. On the WAN side, pretty typical. WAN interface is ETH1. On the LAN side, as I mentioned, Wi-Fi 1AX to connect to our wireless LAN port. We have one client, and we've specified a LAN IP. And we've specified our wireless 802.11 settings. We've also, in this case, we have the multi-port add-on enabled. So we've also specified ETH2 and ETH4 as additional LAN interfaces. I do recommend, if you have the multi-port add-on and you're looking to do QoS testing, at least be very aware of the use same LAN interface test var and our stack rotation logic. It can be somewhat confusing to rotate through the stacks when you're trying to run QoS testing. So, I recommend actually using the same LAN interface and being very deliberate about which interfaces you're testing with. However, you can certainly arrange the test list in such a way that it makes sense to rotate through the stacks. So as I mentioned, the configuration on CDRouter side is very straightforward. Take a quick look at the package here. Again, this would be what a full QoS testing package would look like. We'll get into it later, but actually, in general, I would recommend not including download and upload in the same package. And again, that's because in many cases, you may only have be experiencing congestion or the need for QoS in a single direction. So now that we've looked at CDRouter's configuration, we'll take a moment just to mention the DUT configuration. And I don't have a lot to say about the DUT configuration, unfortunately. I wish I had a lot more to say about it, but what I can say is that, and you all will likely know it better than me, is that it varies. Each DUT is designed to do different things depending on its what its use cases are, the target consumers, and so forth. So this is something where, we'd really appreciate the opportunity to work together to figure out what the correct configuration would be, how we could potentially update, add to, or change our CDRouter tests to handle different configurations. What I will say is that at the end of the day, when it comes to testing QoS with CDRouter, the most important thing will be to reference back to those queues that I mentioned earlier in the different DSCP diffserv tins. In this example, and it's a little bit small in this slide, but hopefully you'll be able to get the idea of it. In this example, we're looking at OpenWRT as our standard. And the only thing to point out here is that this would be a pretty typical set of queues. There's not a whole lot going on here. Everything is defaulted, and there actually aren't any queues here. It's just the default queue. After configuring QoS, however, and this is really small, I think maybe the next slide might make this a bit bigger for us. So this is basically the same output, but now you've seen that there are some blurry columns here that have been configured, and they are for the different tins that we mentioned earlier. And here they are a little bit more visible. So as I mentioned, bulk, best effort, video, and voice. So this is what CDRouter is expecting the DUT to be configured with. If the DUT isn't configured with these tins, no harm. However, you might just not be getting the results, or CDRouter may not be able to determine pass fail as you'd expect, right? The test will still run, it just won't be in the correct initial state that CDRouter expects. So here we have our DUT, which is OpenWRT again, with these tins configured. So yeah, switching back to our demo. Before we go and dig through the logs and things like that, I want to mention the test process. How we do this is kind of exciting, actually, kind of interesting in that we want to figure out what an initial baseline is, what initial baseline speed for our QoS testing is. We're used to, on a DUT or wanting to know how fast to run a speed test, wanting to know how fast our device is performing. We do the same thing here in CDRouter built into the test case. So again, for our configuration as we've set it up, we have a client for each LAN interface, the wireless and the two wired clients. So these are represented by the vertical bars here in this graph. As part of the test process, we're going to go ahead and do an initial measurement of bandwidth for each client on each LAN port. This is going to be independently, one at a time, and it's going to run for the duration of perf duration. So for example, if we have a duration of 10 seconds, client one will do a download or upload test, as the case may be, to determine what its baseline is. When that's complete, client two will go ahead and run a speed test, followed by client three. So you can see at this point, perf duration is really the duration that one of these clients will run the performance test for, times the number of clients you have. So again, if it's 10 seconds here, we're up to 30 seconds for what I call phase one of the test process. Phase two is when we actually turn on our DSCP code points and actually run the QoS test. So based on those initial speed measurements, we go ahead and determine and the threshold for the particular code point, we determine what the expected throughput should be for that traffic. So you can see then that the total duration of a test case would be the phase one duration. In the example I just cooked up, 30 seconds, plus the one more round of the perf duration. I don't think I mentioned this. Important to point out that for this phase two here, all clients are running at the same time. So unlike the measurement phase, they're running independently. Of course, in order to generate enough traffic and cause QoS to occur, we've got all three clients here running simultaneously, generating traffic with their code points. And we're going to look at the results they got later. So the overall time would be, in this case, 40 seconds. And here's just another slide that kind of in words on paper explains what I was just talking about in terms of determining. So if we suppose we had a 900 megabit per second measured bandwidth, and say it was a diff_serv4 video threshold at 50%, we would expect a perf threshold during testing to achieve somewhere around 450 megabits per second. In the third column, I kind of, again, for those of you who are very familiar with our performance tests, the measured bandwidth would be somewhat analogous to perf bandwidth, and the expected perf threshold in this case would be somewhat analogous to perf threshold test vars. So we're not ready to wrap up yet. Let's go right into the demo and start digging into CDRouter a little bit. So in this case, we're going to look at some upload test cases for QoS performance. We have a few tests configured, 3 to be exact. We have test 1, 6, and 11 from our IPv4 upload package. So these are video, best effort, video and voice and video. I want to mention again, I don't know if I've emphasized this enough, what we have specified in the test case name is the primary or application flow as well as the background flow. But I've been talking about having 3 clients. If we refer back to our slide here with the 3 clients, and I mentioned earlier that we have 3 ports connected, what's going on that third client is the question. And the answer is that's where our best effort traffic is coming from. So what CDRouter is going to do for each client that you have configured, we mentioned in our config file that we had 2 additional LAN interfaces. You could have additional LAN clients or additional LAN interfaces configured. And what CDRouter will do with those is go ahead and create additional background flows using best effort traffic. Again, to fill up that pipeline and give the device every opportunity to perform QoS according to what you're looking to test. So these are the 3 test cases we have, and we can go ahead and look into the results a little bit here and see how these run. Start is no different from what you're familiar with any of the other CDRouter test cases. So we'll dive right into what the test case output looks like. Again, this is a perf upload test. So this should look pretty similar to what you're familiar with performance test cases. We're setting up a WAN and LAN test, and we're looking at the parameters here. And I point this out because for a couple of reasons. First, this is going to be the start of what we referred to as phase 1 initially. So this is starting the measurement flow. We know it's a measurement flow for a couple of reasons. We haven't specified a bandwidth. So we really would like to go as fast as we can. And the reason is, we want to get that high speed measurement to determine where to set our threshold for later testing. We have used UDP, and again, there's no code point set for this. Testing runs, and we get a result. We say UDP upload throughput of around 574 megabits per second. Again, we didn't have a threshold set. We were just trying to get a baseline measurement. Something new here that we've included for each round of tests for each client is just some output from the perf session itself. Pretty much all the same information you're used to, maybe a couple of extra things that we'll go through later in terms of thresholds and DSCP code point. So this happens 3 times, 1 for each stack. That's the second measurement. And as we scroll down, there's the output here, 572, maybe not surprising. And then a third measurement flow for the third interface, 583. And again, some more output here. So now shutting down performance test, and we've printed out here our measurement throughputs to coincide with phase one. We're not done yet. We keep going because now we actually need to start our QoS testing. This is where things are going to happen in parallel in phase two. So you'll notice a difference now. For the first stack, we have set a bandwidth of 574 megabits per second to coincide with our initial measurement. We've also set a code point to coincide with video and its UDP. So we've started the LAN client here, and the test connection is set up, but the test hasn't started yet because we still have two other clients to set up. So here we have 572 to coincide with our second one. And this is a best effort flow. So the code point is 0. And because I mentioned we have 3 interfaces, here's another best effort flow, again at 583 for a best effort flow to help fill the pipe. Now that all 3 connections have been set up, we're ready to start simultaneous performance test measurements. Again, this is pretty familiar output, no different from the earlier measurement output, but things changed a little bit here. We see that we had a UDP upload throughput of 276 is greater than our threshold of 258. So something different happened here. And when we look at the results and some of the extra things that we printed here, we've mentioned video and the code point for it. We've also mentioned the threshold. And now we've said, okay, the original bandwidth that we measured was 574. We set our threshold to 258, or about half of what our initial measured throughput was, and experienced a rate of 276. We'll go through a little bit more at a table below. So this happens again for each of these flows. And now at the bottom is where we've really broken down exactly what happened in each of the phases. So you'll see 6 columns here. One for each of the measurement flows on LAN, LAN 2, and LAN 3, and then the actual QoS flow for each as well. And you can just tell the difference here based on the DSCP test. So what's interesting to point out here is indeed our video flow used around 50% of the overall measured throughput, while our best effort flows used the remainder. Again, I say remainder because they're best effort, right? So the remainder after the 50% of the video throughput is applied is 50%, divided by the 2 best effort flows would be 25%. Something interesting that's happened here, and don't get confused by the 54% here, what that's actually showing is the loss, in this case, UDP loss. 50% is actually, 54% is actually probably expected, right? What we've done here is we've transmitted at 100% of what we measured, and we've only allowed 50% through, so it makes sense that around 50% would be lost. And similar numbers here on the best effort side. It's a little bit higher. So that's an overview of the video and best effort one. And we'll take one more look here, maybe at the video and voice flow. And I'll just scroll down to the bottom here, and we can just see what might have changed. Again, we have 50% for the video flow, 25% for the voice flow. Again, if there were multiple voice here, this would be 25% for all of them. But in this case, it just so happens that it's 25% for voice, and the remainder after you've added up the other flows is 25%. I should say difference after adding up the other flows. So again, it looks like the device did queuing as we expected. Our thresholds were met as we expected them to be. We'll look at the voice flow here, 583. Around a quarter of that is what we expected to get through. And indeed, a little bit more than that is what got through. I should point out again that these thresholds are minimums. Going over is great, and that's a great situation. It's just we're going to flag it when it goes below those thresholds. I included this result here because I thought it would be useful. These results here are actually, while there's a lot of output here, there's not a whole lot of debugging included. We do have the ability to turn on a lot of extra debugging for this that may or may not be helpful depending on what we're trying to accomplish. but those flags exist. And if there's anything you need more help with, we need to dig into it. You might expect to hear from us to enable some of these debugging flags to get a closer look to see what's happening. So one more thing I wanted to point out here. I mentioned earlier in terms of there only being congestion in a single direction. And the reason for that just being that, well, if a device, in this case, in the download direction is generating a gigabit per second traffic on the WAN, well, you have a lot of LAN ports to divide that traffic among, and that LAN port can't run faster than a gigabit, which is equal to the speed of any of our LAN ports. So in the download direction, there isn't actually going to be a whole lot of congestion here, which is why I recommended before, probably you don't want to mix upload and download test cases too frequently. But I ran a result here that included some download tests just to see what would happen in that case. So in this case, some different things happen, right? We see that CDRouter flagged a problem here. So now we're familiar with what those results look like. I'll scroll right down to the end. Actually, maybe it would be helpful for starters to filter on our pass-fail and just to see what this looks like. So again, we ran measurements. And maybe it's not surprising, again, to see that we ran pretty fast on each of these interfaces initially. However, we did flag a failure here. The download of 311 megabits per second is less than what we expected of around 400. The others, we claim to have passed, but, you know, and they did. Indeed, the threshold is greater, but what's actually going on here? Let's scroll down to the bottom and look at the table and see if we can figure this out. Again, similar table, we have 3 clients, each with a measurement and DSCP test example. So we'll work backwards, starting from LAN 3 and LAN 2, which are really similar. So we measured an initial throughput of, you know, pretty close to line rate, if not exactly line rate. 25% of that would be 215 megabits per second, and we got 311 megabits per second. Okay, cool. That happened for both of those. But our video stream here didn't fare so well. So we expected around 50% of 893. We calculated that to be around 400 megabits per second, and we only had 311 megabits per second. So what it actually looks like here is that if we look at these results, the device didn't do any queuing. It treated each traffic fairly. That's not actually entirely correct, though. All it was able to do was first packet in, first packet out. All it could do is get the traffic it received on the WAN and forward it to the LAN as it received it. So this was actually done by the way the traffic was being generated on the WAN side, rather than anything special having to do with QoS or diffserv. The other interesting thing here is you'll notice there's no loss or very low loss. Again, the reason for that is it just processed packets as they were received. They were coming in at line rate. Again, because they're all connected on the same port, it wasn't 3 times line rate. It was just the line rate of 893 or 956 probably. We do print out a message here. It's not a pass or fail message. It's meant to be informative, maybe, because it's really hard actually to determine exactly what's going on in the particular test setup. But we note that, hey, there wasn't any packet loss. It was less than 5%. Maybe there weren't any bandwidth constraints here. And we flag that for each of the 3. So this is something you might see, if it may be very obvious what's happening in your particular setup, or it might be something that we would want to dig into further with you. Because again, it's not always obvious if queuing is happening. In this case, I know it wasn't. However, it may not always be that obvious. And these messages could be helpful, or they could be a red herring. That's something we'd want to dig in more with you. So that's what our DSCP tests look like in the wild when they're running. Flipping forward, we have a couple of other points to make in terms of wrap up here. There are some caveats. Performance testing is a moving target. Unlike functional testing, it's really obvious. We're looking for a pass or a fail. It either works or it doesn't. Sure, there are cases where we're wondering, did it really work? Is that a false positive or false negative? Performance is different because it's changing, right? First of all, we always want it to go faster. How fast it should go is dependent on who you're asking or the type of device. Where we help here is to create repeatable and consistent results for the performance testing, as well as to set some expectations in terms of the thresholds, the DSCP TINs, and kind of setting a target that makes sense, not just from an overall level on the device, but indeed in each test run where we've done a measurement every time we test to see what's changed and what hasn't. We mentioned earlier that QoS DUT configuration will vary. What I found is it's a trade-off between simplicity and sophistication. Obviously not all users will want to or even be able to do a very complicated configuration that includes lots of different TINs and thresholds and Qs and setting the speed. On the other hand, not having all those knobs may be a trade-off in terms of exactly what we can do from the DUT side in terms of really optimizing its performance. So I'd say here that CDRouter will help narrow down which configuration elements are most important to that end user, and maybe even find a configuration that is sort of the perfect one that will apply for a majority of of use cases for that user. I also want to point out that queuing is a somewhat CPU intensive process. It takes some amount of effort on the part of the DUT to determine how to handle every packet that comes in. And not all DUTs will be the same, of course, but for some of those, that's a CPU intensive process. Will mean there will be some changes from test case to test case. Any extra flows, any extra processing the device is doing, extra traffic that's hanging around on other interfaces, could impact results. I think CDRouter's traffic flows and thresholds will help ensure ongoing passing results. Using a consistent threshold and rate will do that. And I also want to mention here, it might be something to use in combination with stability packages. We sort of talk a lot about functional tests and performance tests. Stability is kind of where the two come together, and we want to see that things continue to work over time in spite of any extra traffic or additional processing the device may need to do. So that's certainly something to keep in mind as we go. And it could be something as simple as, and it just struck me as I was thinking about that and mentioning that, it could even be something as simple as internet connection sharing. And I was just about to look, I don't believe I have this set up here, but that could be, additional processing a device might have to do. So in this example, it was off, and that was probably a good decision. We want to make sure the device is isolated and that our performance testing is, as stable as possible. So with that, I have some more resources here. As I mentioned, we talked about Cake earlier. I mentioned DiffServe and the different models for queuing and per hop behavior. RFCs are what they are. They tend to be very verbose, but they do have a lot of information and, can be a good resource for when you just need to get back to basics and figure out, what's going on from a building blocks perspective. I mentioned OpenWRT and their queuing model, and that's the reference here. We didn't go a lot into the OpenWRT configuration intentionally, but if you want to, again, get a baseline for what an open source example of that looks like, that would be a really good resource to look at. Additionally, I think Jason referenced it earlier, we have our QA Cafe article, How to Test DSCP, and of course, our user guides for performance in general, which are a wealth of information for how these tests are running and what to expect and what you'll need to configure to really get those results you're looking for.